Alrighty, for our last section, 12.6, we have volume of spheres. Our goal is to find the surface area and volume of spheres and hemispheres. We actually started surface area, but we're just going to practice it a little bit more. Before we get started on that, let's talk about frustums again. We want to find the volume of them and the surface area. Let's talk about the differences and similarities between the two. Remember, a frustum is going to be a cone that's basically chopped off by another cone, and it's going to be chopped off completely with a flat surface, so this is called a cross-section. Okay, and same thing for a pyramid. It could be a pyramid chopped off by another pyramid. So to find the volume of that, we just take the volume of the big solid, I'm going to say, because it could either be a pyramid or a cone, and subtract the volume of the small solid. Okay, when we get to surface area, think about surface area is going to be a little bit different. We still got to subtract, so we want the surface area of the big solid minus, but we're not going to take the whole entire surface area of the small one, because if I think about this, if I draw a cone here, I don't want this part subtracted. Okay, I want it added. So I'm going to subtract the lateral area of the small solid. Okay, and then I have to add the area of this part here. Okay, so I'm going to add the area of the top base. So you can see kind of the differences and similarities there, but we're going to go ahead and move on to spheres. Volume of a sphere is 4/3 pi r, not squared but cubed. Okay, volume is cubed, so you can remember that a sphere is going to be r cubed. The third power. Let's go ahead and try number 1. We have a circular amphitheater that's having a hemispherical dome built over it. So I'm going to draw a hemispherical dome. Okay. I'm going to go ahead and use the surface area formula because it's asking for square feet, and I know it measures 420 feet across. 420 feet across, that tells me that is the diameter. Remember, I need radius for surface area. Surface area is 4 pi r squared. Okay, because this is a hemisphere, I'm going to divide this by 2. So go ahead and plug it in and calculate the answer. Okay, we're going to plug in 210, not 420, so 4 pi 210 squared divided by 2, 88,200 feet squared. Okay, I'll go ahead and try for the volume. Volume formula, 4/3 pi r cubed. Go ahead and plug that in. Remember, we are still dividing this by 2 because we only want half of the dome. Okay, if you calculated this one right, it's 6,134,000 feet cubed. Okay, let's talk about our tennis ball problem. Jar of tennis balls holds 3 balls. If the jar is perfectly sized so that 3 stacked balls fit inside it, what's the volume of the container? We have the diameter of the tennis balls is 3. Okay, remember diameters go both ways, so that's going to give us our height. If this is 3, so is this. Okay, so this is going to be a volume of a cylinder, which is pi r squared times the height, base times height. Go ahead and plug that into the formula and solve. Okay, so I'm plugging in 1.5 because that's my radius, half of 3. My height is 9, 3 plus 3 plus 3. And multiply that out, you get 20.25 inches squared. Cubed, I'm sorry. Volume of the air inside the tennis ball from the above problem. So for volume of the air, I'm going to take the volume of the cylinder and subtract 3 volumes of the spheres because there's 3 inside. Okay, go ahead and try that one, and I'll put up the answer in a minute if you want to pause it right now. Okay, plugging it in, 4/3 pi, 1.5 to the 3rd power. Okay, and just realize this should have a pi on it. So should this. So we have 13.5 pi, 20.25 pi minus 13.5 pi. And my final answer, 6.75 pi. Again, this is inches cubed, and that is the space around the tennis balls, because we're asking for this part around here. And last part. Alright, last part we kind of touched on last chapter. This is ratios. So ratios of sides or perimeters. I'm going to add perimeters in here. Is A to B. We know ratio of areas is A squared to B squared. So the volumes is A cubed to B cubed. And this is for similar polygons only. So go ahead and fill these out. Or those sides to areas and areas to volume. So ratio of sides, if I square 3 and 5, I get 9 to 25. And if I cube 3, 3 cubed is 27. 5 cubed is 125. Okay, if I start here, I'm going to take the square root of both and go backwards. So 64 to 49, square root of 64 is 8, square root of 49 is 7. Okay, now I have this one, so I'm going to go back here. I can't go from here to here. I have to go from sides to volumes. So 8 cubed to 7 cubed. 8 cubed is 512. 7 cubed is 343. Okay, let's go from reverse to volumes to sides. So for this, I'm going to take the cube root. Okay, cube root is like this. You can find that in the calculator. Okay, or think about what number multiplies 3 times by itself to get 8. 2 times 2 times 2 is 8. So 2 is here, and then the same thing for 1. What number multiplies by itself 3 times to get 1? So that's 1. Okay, 2 squared is 4, 1 squared is 1. And the last one, 27 to 125. Well, I'm going to take the cube root of 27. What number multiplied 3 times by itself is to get 27? 3 times 3 times 3 would equal 27. So the cube root of 27 is 3. And the same thing here, cube root of 125 is 5. 3 squared is 9, 5 squared is 25. And that completes the chart. Okay, that brings us to the end. Unit, and we are all finished. Nice job!